Hello friends, today we are going to discuss about the method of variation of parameters for linear differential equations of higher order. In my last lecture, I have explained the method of variation of parameter for second order linear differential equations. Now let us consider the third order differential equation for simplicity. You can apply the same method and you can extend it for more than third degree order as well. That means on fourth order, fifth order and onwards. Now the general third order differential equation is looking something like this: y3 py2 qy1 plus ry is equals to s, where p, q, r, s are all the functions of x. The corresponding homogeneous equation of the equation number 1 is given something like this. That means the right hand side is taken equal to 0. And since it is a homogeneous differential equation, let us consider u, v and w are the solutions of this homogeneous differential equations. Therefore, its general solution, or we can say the complementary function, is something like this: y is equals to c1u c2v plus c3w. It is just a general solution of this homogeneous equation, okay, not of this equation number 1. Clear? So now where u, v and w are the linearly independent solutions of equation number 2. Now let us take that C1, C2 and C3 will be replaced by the functions f, g and h, because we need to find out the solution of equation number 1, where the right hand side is s and that is also a function of x and it is non-zero. So I have taken in place of C1, C2 and C3, which are the arbitrary constants, I have taken the functions f, g and h. Clear? Now what I will do is I'll find out y1, that means the first differentiation, then second differentiation and then third differentiation, and put all those values in the equation number 1, and then I try to find out my answer. Now okay, so let us start with the y1. Y1 will be the first order derivative of y, so it will be done by using the differentiation of functions of multiplication of functions. F and u are multiplied together, though f1u plus fu1, g1v plus gv1, h1w plus hw1. Now since we are having the three functions f, g and h, and whose values are desirable, so let us consider f1u plus g1v plus h1w is equals to 0. So call it number 3. So fy1 will be the remaining part, fu1, gv1 and hw1. Now again differentiate this with respect to x. Use the method of differentiation of multiplication of functions. So fu1 are multiplied together, so f1u1 plus fu2, and similarly you can differentiate gv1 and hw1 as well. Now since there are three functions f, g and h કે જેમની આપણે કિંમત શોધવી છે, તો આપણે એના માટે ત્રણ વેરિયેબલ્સ છે, ત્રણ ફંક્શન્સ છે, તો ત્રણ ઇક્વેશન્સ હોવા જોઈએ. આપણે એક ઇક્વેશન આ મેળવી દીધું છે. So let us consider the another equation as f1u1 g1v1 and h1w1 is equals to 0. That means f1u1 g1v1 h1w1 is equals to 0. So when these three are added and it equals to 0, y2 will be the remaining part. That looks something like this. Okay, so again differentiate it, same rules, same conditions. Now you are having the values of y1, y2 and y3. Now put all these three values into the given equation number 1. Okay, and you are left with f1 u2 g1 v2 h1 w2 is equals to s. Okay, and now you are having three equations. This is the first equation, this one is the second equation, and this one is the third equation. Now try to solve these three equations together for the values of f, g and h. So you will find out f1, g1 and h1 from these three equations using the Cramer's rule, or you can eliminate f1, g1 and h1 and find out their values. Then integrate those three values and you will find out the values of f, g and h. Okay, now let us use it for solving some examples. So here is the example that solve y3 minus 6y2 plus 11y1 minus 6y is equals to e raised to 2x. Now you can check that the coefficients over here are constant coefficients. Okay, so we can rewrite this one as y3 minus 6y2 plus 11y1 minus 6y is equals to 0. This is the corresponding homogeneous differential equation of the given equation. Okay, now you can rewrite this one in the terms of operators, that y3 is d3y, this is 6d square y, this is 11dy, and minus 6y is equals to 0. Now you can take y outside and you are having the cubic equation d cube minus 6d square plus 11d minus 6. So the auxiliary equation for this equation is given by this one. So m cube minus 6m square plus 11m minus 6 is equals to 0. Now since the sum of the coefficients of odd terms is minus 12 and sum of the coefficients of the even terms is also 12 and that one is a minus 12, so 1 is the one root for this equation. So m minus 1 will be the one factor. So I have taken something like this. Now for getting m cube I have multiplied by m square and so on. We will get this something like this: m minus 1 m square minus 5m plus 6 is equals to 0. And since you can factorize it in this manner: m minus 1, m minus 3 and m minus 2. So we will have values of m is equals to 1, 2 and 3. So corresponding complementary function is c1 e raised to x because of this one. Since this 1, 2 and 3 are the distinct roots to the auxiliary equation, the solution, or we can say the complementary function, is c1 e raised to x, c2 e raised to 2x because of this 2, and c3 e raised to 3x because of this 3, be the solution of the homogeneous differential equation, this one. Okay, now in place of c1, c2 and c3, let us consider f, g and h. Okay, and suppose that this is the solution of the given equation. Is that okay? Now what we will do is find out y1, y2 and y3 and obtain three different conditions. So y1 is the first derivative, that means f1 e raised to x, and now f as it is and e raised to x differentiation is same to same e raised to x. Now differentiation of g is g1 e raised to 2x as it is, then g as it is, and differentiation of e raised to 2x is 2 times e raised to 2x. Similarly you can differentiate the last term as well. Now consider f1 e raised to x, g1 e raised to 2x and h1 e raised to 3x is equals to 0. This is the first condition that we required. Now after taking it to 0, the remaining terms are something like this. So y1 is something like this. Now again differentiate with respect to x. So f differentiation is f1 e raised to x as it is. Now f as it is and derivative of e raised to x is e raised to x. So again differentiate this term as well. You will get this term. and differentiate 3h e raised to 3x, you will get this term. Okay, now again let us consider f1 e raised to x, 2g1 e raised to 2x. See, here we have to take the constant coefficient as well with this 2g1 e raised to 2x. Then 3h1 e raised to 3x is equals to 0. So this is the second equation which is required. Okay, this is the first one that we required. This is the second one that we required for finding the solutions of f1, g1 and h1. Now y2 will be this much. Again differentiate, you will get y3 f1 derivative e raised to x as it is, f as it is, and derivative of e raised to x something like this. So again differentiate for g e raised to 2x, that will gives you this much answer. And so you will have the values of y, y1, y2 and y3. Substitute in the given equation number 1. That means our main question. So after putting all those values, you will have something like this. Now see what we get is, so as you can see this line, this f e raised to x. Again, where is f? This is minus 6f e raised to x. This is 11f e raised to x. And this is minus 6f e raised to x. Now you can check. This is 1 time. This is minus 6 time. This is 11 time. And this is minus 6. So 1 plus 11 is 12. And minus 6 minus 12. So they are cancelled. So this one cancelled. This one cancelled. 4 terms were cancelled. Now you can check the zigzag line. This is a multiple of g. This is first term. This is second term. This is third term. And this is the fourth term. Now you can check what are the values we have. So you can check the first term will gives you 8 times gx. 8 times g e raised to 2x. The second term will gives you what? This is 4 and this is minus 6. So it is minus 24. So it is minus 24. This is 2g and this is 11. So we will have 11 2s are 22. And now g into minus 6. So that is minus 6. And when you equate this 4 terms, it will be what? It will be 0. So this terms with g is also vanished. So this terms with multiple of g were also vanished from this one. Now again find out the coefficient of h. So this is the first one, this is the second one, this is third one, and this is the fourth one. Okay, so those are the 4 different values of multiples of h. So what will be the coefficient of h in the first one? That is 27. Now in the second term it is what? 9h e raised to 3x, and this is minus 6. So 9 6 are what? 54, but it is minus 54. Now this is 3h and this is 11. So it is be plus 33. And what will be the last term? H e raised to 3x. So it is minus 6. So minus 6. Now just add all these terms. So 33 and 33 and 27 will gives you plus 60, minus 54 minus 6 will gives you minus 60. So it is also 0. So that term will also vanish. So h term will also vanish. This term are also vanished. Okay, so what you are left with? f1 e raised to x, 4g1 e raised to 2x, 9h1 e raised to 3x. So these are the only 3 terms we are left with, and right hand side is e raised to 2x. Okay, so that is the required third equation. This is the first one, this is the second one, and from this one we get the third equation. And so this is the required third equation. So now using the third number, fourth number and fifth number, what are the 3 and 4 which we have discussed in the previous page? Okay, so solve those three for f1, g1 and h1. So I have written again over here, this is the third equation, this is the fourth equation, and this is the fifth one. So first of all, let us consider the subtraction of first and second, or we can say third and fourth. So f1 e raised to x, f1 e raised to x were cancelled, and we were left with g1 g1 e raised to 2x. This is minus 2 g1 e raised to 2x. So when this g1 and this minus g1 minus 2 g1, it will gives you minus g1 e raised to 2x. This is h1 and this is minus 3. So it is minus 3 h1 e raised to 3x. Okay, so using this first two and eliminating f1, you get this equation. Clear? Now put this equation, this minus will be taken common, so it will be positive, this will also be positive, and now again use this term, that second minus third. When you take second minus third, again f1 will be vanished, and this 2g1 minus 4g1, or we can say 4g1 minus 2g1, that is 2g1, 9 minus 3h1, so that is 6h1. So using this one and using this one, so what we are left with, here we have need 2, so let us multiply it by 2 over here. So when you multiply it by 2, this were cancelled, and so this will be 4 because multiplied by 2, and this is minus 6, so it is minus 2, and 0 minus e raised to minus 2x. So we are having h1 is equals to this much. Put this value of h1 in the equation number 6, that means this equation. Okay, so when you put over the here, this is the sixth equation, g1 e raised to 2x, 2h1 e raised to 3x. Put the value of h1 over here, it is 1 by 2 e raised to x, so 2 were cancelled, e raised to 3x and it is e raised to x, so we are left with e raised to 2x only. This is g1 e raised to 2x plus e raised to 2x barabar 0, so g1 will be minus 1. So you got h1, you got g1. Put these two values into third one, this equation. You will find out the value of f1. So this is the third equation in which I have put it g1 and h1, and after simplifying, this is negative because of minus 1 multiplied, and this is this one. So f1 e raised to x is equals to 1 by 2 e raised to 2x, and so when e raised to x is divided from the right hand side, you will get the value of f1. Now you will having f1, g1 and h1 all three. Now integrate these three terms with respect to x. We get f on integrating f1, 1 by 2 e raised to x, so 1 by 2 e raised to x plus c1. On integrating g1, you will get g minus 1 dx, so minus x plus c2. You will get h on integrating h1, and you will get something like this. Now put f, g and h in y. So f e raised to x, g e raised to 2x, h e raised to 3x. Value of f is this much into e raised to 2x. g1 into e raised to 2x. gh into e raised to 3x. You will get answer something like this. Okay, so let us stop over here. So this is the method for solving the higher order differential equations using the variation of parameter. Okay, goodbye.